Hi, I'm Paul Brodie, shop here, Mitch behind the camera. We got some stuff to do today. What's new? I got some aermacchi parts that are nickel plated and anodized. This is the clutch hub that got made in a previous episode. And this has been hard anodized. So I know the friction plate has to rub against this surface here. So we'll see how that hard anodizing works. This is just regular anodizing. This is pewter, this is black obviously. Got the oil lines done. There's the washer and the circlip for the rear hub. This is the tack mount here. Oil lines, these banjo bolts, and so they've been drilled for safety wire because all oil lines on a race bike have to be safety wired. And I have a little jig that makes that. That's the oil filler cap, and it needs to be safety wired as well. So we're good there. One of the viewers wanted to see an aerial shot of the aermacchi tools, the special tools. So Mitch is going to show you that. There's a few tools there. And then we're going to talk about valve keepers. These are the little pieces that go in between the valve and the valve cap. Can you see these two little pieces? This is a 7mm. Can you see there's, it's not a groove, it goes into a groove, so I'm not quite sure what you'd call that. But it has to fit really well. So you can see this one. See, that fits well. That's a good fit. Now on this valve here, this is out of the engine which I built in 2001. I can't remember if I bought a set of keepers or someone gave me a set or I made a set of keepers. 2001, can't remember. So I've been looking for keepers and apparently I don't know what to order. So I started making phone calls. I went online and I looked up machine shops in Langley and I found a few. So I started phoning, and the third one I phoned was NT Machine. And I told them that I'm looking for valve keepers, and they said, well, come on down, we've got some valve keepers. So I went down there a few days later, and this is what they had. Amazing selection. I thought that I'd go in there and I'd sit down somewhere and I'd look for valve keepers, but he handed me this thing and he says, here, you take it away, you bring it back. He didn't know me, he didn't have my name, phone number or anything. And I said, do you want my name or phone number or something? He says, just bring it back. So I figured it was, I guessed, 8-9 pounds of valve keepers, but it's actually 13 pounds. And I have gone through this whole thing. I had help from a friend, Mick Hart. We went through this whole thing looking for keepers. So the closest we could find, I'll show you what the closest is. There's two different kinds here, and each of them doesn't fit quite. So can you see this one? Can you see how they're way too far in? Because the OD is too small. So those didn't work. And then we found these ones, and they're a different shape on the inside. So it looks good, but can you see how it wiggles? It's not the right taper. Well, something's going on. So neither of those work. So what I have to do, I realized after looking through 13 pounds of valve keepers, is that I have to make my own. So I got some metal here. This is 1144 that you've probably never heard of. I looked it up in my book. So what we're looking at here is the carbon content. So this has a fairly high carbon content, and we're also looking at the tensile strength, 125,000, and machinability is at 82. Now it's not a scale of 0 to 100 because I've seen one that was 195, but this means that it's fairly easy to machine. So that's what we're using. So I've got a little sketch here that I'm going to make you to show, because I had to think about how am I going to make a valve keeper, because it's got a bore that fits around the valve, and then it's also got a section that comes in for the groove. So what I've got right here is an outline of this piece here. So I'm going to show you what I'm going to do. I'm going to drill a hole first. So the hole is going to go like that. So the hole size is that size. So that's going to be the smallest part of the keeper. Now I have to open up. So I'm going to use a drill, and we're going to open up to 6 millimeters. Like that. And I didn't have a reamer, so I had to buy a reamer. This is a 6 millimeter reamer, and I remember, it doesn't seem like that long ago, I'd pay like $16, $18 for a reamer, small one like this. $31. Everything is more money, it seems. Okay, so now what I want to do is, I know the width of the groove, and I can measure up from here. So what I have to do is to face off the end to the same width of the groove from there to there. So I'm facing off the end now. This is my plan. And having done that, now I need to put a radius on there. Use my red pen now. So this is going to be a radius like that. And how I'm going to do that, it's going to be spinning in the lathe, and I got a scraper. I sharpened it up a bit. And so as the lathe is turning, I can make a radius there. And I can also go inside and also work on that radius as well. Then the next thing to do is to make a taper. I think it's a 7-degree taper, but I'm not sure. We'll check that as well. So now I got a taper that's looking like a keeper. After that, I take it out of the lathe, hold it in the bench vise, and I hacksaw down to here, and then I can cut it off, and then I see how it fits. And if it doesn't fit very well, then I have to make another one. So this is the plan today. And then if we have time, I think we will, we're going to work on aermacchi flywheels. There's a couple things we have to do. So first of all, I'm going to hacksaw this off, face it, and we're going to work on the keepers. I just need one pair, that's all. I'll drill from the other end as well, because sometimes the drill wanders, so this will be a good thing to start from both ends, I think. Okay, that's the first hole drilled. That's the same size as the groove in the valve. So now we have to drill and ream to 6 millimeters. There's a radius there that should fit inside the valve, but it's hard to know if that's right. So anyway, we're going to proceed, and we'll see what happens. So next I have to measure the angle of the valve cap. Okay, so the valve cap is held lightly. So here's my little indicator, and it's in tenths of a thou, so we can make it pretty accurate. So from my thumb to my thumb, that's 1 thou. So each of those is 1/10 of a thou, each of those lines. Okay, so something like that. In England, my father used to be an aircraft inspector, ejection seats, and this is one of the tools he had for looking around the corners to make sure that everything was good. So this was made in either late 50s or early 60s in England. So there we go. Can you see what I'm seeing there? Okay, we're at 0. So over that space of, we're out 2 thou. That's pretty close. Is that close enough? Okay. This is a tap. There we go, we're on 0. There we go, we're outside there. So we're at 1 thou now. You want closer than that, Mitch? There we go. Hitting my lathe with a hammer. That's what it comes down to, doesn't it? Hitting my lathe. That's good. It's a couple tenths max, so we're good. Okay, we have to figure out how long the keep is going to be, and we also need the width of a hacksaw blade. So we're at 392, so if we go out to, if you make the cut at 450, something like that, 445. So that's how far down we go. Okay, let's go to the bench vise, and I'll see how good I am with a little hacksaw. Wow, what a lot of work for a little piece. I wanted to use this hacksaw blade because it's narrow. It gets easier as I go down because it gets a little thinner and thinner. And we're bottomed out. Got some 180 paper here. So there we have oh, you can see the okay, well, let's see how they fit. I'll go grab the valve. See if it fits. See if it hangs up like that one. That's a good fit. Okay, so it's not falling out. And can you see how it's raised up a little bit above this surface here? Well, this one's the same. It's raised up just a little bit above the surface. So I don't think that's going to come. I think that should work. So, wow, what a lot of work for a set of keepers. Here's the aermacchi flywheel that we took out of these cases. That was, I don't know, a couple episodes ago or more. And one of the viewers says, yeah, you have to look inside the sludge trap. I know about that. So this has been a race bike. It's not a street bike, and I change the oil after every race. So let's take out that plug. Doesn't take that long. And let's see how much sludge is actually inside, because He had a concern that there's a bunch of dirt in there. Let's find out. Oh, it went through anyway. Okay, whatever. Not a very long plug. I'm using some grease because then what the grease does is hold the chips and it stops the chips from going down the hole. So we don't have to put a whole lot of threads in, but we are going to put a few threads in here so that the slide hammer can do its job. So I got my long tap handle here so I don't interfere. And it doesn't have to be super straight. 5/16 National Fine. That's what the slide hammer is. So let's find out what's inside here. Whether we got lots of dirt or just a little bit. There it comes. Okay, see it coming out? There we go. Can you see inside? There's no dirt at all. There's no sludge. I'm gonna get another paper towel and I'm gonna wipe the inside. So after a season of racing, that's how much dirt was in there. Almost nothing. So I guess it pays to change the oil, doesn't it? Yes. We can use this, we can use the size of that, and we'll make up another insert and we'll press it in there, and that job is taken care of. This is called press lube, and it just helps to stop seizing. Yeah, that went in quite nicely. So it's all clean. We don't have to worry. We can sleep at night now. We know that the sludge trap is not full of junk. We hope you've enjoyed hanging out in the shop here with myself and Mitch. We worked on valve keepers, a sludge trap maintenance, and I enjoyed myself. So if you like what you're seeing, please give us a thumbs up, subscribe. Mitch and I like coffees, as you know. If you buy us a few coffees, it helps to fuel the channel. Thanks. See you next week. Take care.